Hi subscribers, welcome to our channel. This is Kishore Palwalsa. Please subscribe our channel for more new interesting different types of new classes as well as please support to me. I need always your encouragement. Okay, and also in the previous session already we are discussing about different types of insulators and with that different types of examples, and also different types of transmission losses also. All those things we are learning the before classes. Okay, if you want to see that all those classes, please visit daily our classes. We make you different types of classes in every day. Okay, with your support only, that is possible only with your support only. Okay, so please daily visit our channel for the new concept oriented classes. Okay, and also today we are now going to discussing about, there are different types of transmission lines, okay. Transmission lines. Okay, so coming to the transmission lines types, basically according to the length of the conductor, are also called as according to the length of the line, as well as according to the distance of transmission lines, are also called as according to the distance of transmission lines. Basically the transmission lines can be classified into basically three types. Okay, one is the short transmission lines, okay, which is very important, all those different types of transmissions. Okay, so one is the short transmission line, and second one is the medium transmission line, and third one is the long transmission line. Okay, long transmission line. So these are the three different types of transmission lines. According to their distance, we can simply classify all those things. Okay, so coming to the short transmission lines, basically the length of the line, okay, this is like a, for example, let us consider like a transmission line. Okay, this is like a transmission line, a transmission system. Okay, basically the length of the line which is may contains below 90 km. Okay, whenever the total length of the line are also called as length of the conductor which is may contains below 90 km, so then only simply we have to consider as a like a short transmission line. That can be coming to the short transmission lines. Okay, so that is the representation of short transmission lines. Simply we can identify it according to the distance of transmission line. Okay, as well as coming to the transmission lines, so basically in the all those transmission lines there are different types of line parameters will be existing. Whenever supply will be flowing from the entire transmission line. Okay, so basically what is the line parameters may be consisting in that all those transmission lines? Basically may contains, one is the resistance, means R, resistance, and second one is the inductance, and third one is the capacitance. Okay, so these are the mostly three parameters which will be existing in that transmission line, Without these line parameters we can't flows to the current to the entire transmission line from generating station to load center, Okay, so which are the mostly important, both resistance and inductance and capacitance, which is called as line parameters. Okay, which is called as line parameters, also called as like a lumped parameters, Okay, and coming to the, here short transmission lines, in the short transmission lines basically contains to the both resistance and inductance only, which will be consisting in that short transmission lines. Okay, why? Because in this the distance will be very low, so that's why the majorly which is influencing on both resistance and as well as inductance only. Okay, as well as here, so basically coming to the representation of diagram, so here let us consider this is the sending end voltage to the entire transmission line. So like this is like a some generating station, like a different types of conventional sources. With the help of different types of conventional sources we can generate the electrical supply, so that can be fed to the so transmission line here also. So this is the sending end voltage, and again the short transmission line may contains both resistance, already told you, both resistance as well as inductance. Okay, both resistance and as well as inductance, which is connected in series. Okay, and also so finally here we are connected to the total supply will be flowing to the finally which is goes to the load center, finally which is goes to the load center. Okay, so this is the basic representation for the short transmission line. This is the basic representation for the short transmission line. Okay, so basically here this is the resistance which is indicated as the R, and also this is like a inductance, so that is like a some X or some XL. Okay, why? Because the inductance may contains internally some property of reactance, that's why we have to indicate as, like XL. Okay, that's why we have to indicate as some XL. Okay, so are also called as simply some X, X as some X by 2, whatever may be that we can indicate the parameters representation. Okay, here from this, so different parameters we can calculate to the impedance also from this transmission line. We can calculate to the impedance also from this short transmission lines. Okay, the impedance means here basically given as, that is given as Z. Okay, Z is equal to, how can we calculate it? Z is equal to, so basically we are represented as root over R square plus XL whole square, root over R square overall root over R square plus XL whole square. This is the formula for the calculation of impedance value in the all transmission line, according to the parameters existing, Okay, so this is like a short transmission lines. Here only two parameters may be consisting, so that's why here root over R square plus XL whole square. So if you want to go for the medium and long, so so some external parameters will be adding to the here impedance formula. Some external parameters will be adding to the here impedance formula. Okay, and also here, so this is the sending end voltage, so Vs, and also some current will be flowing to the entire line, that is like a some IR, some IS. Sending end means sending and current will be flowing, that is like IS. Okay, IS means sending and current will be flowing I, which is represented as I. So that's why IS will be flowing. Okay, but sending end lo some current flow అవుతుంది కదండి, అది I అనుకుంటే, సో sending end flow అవుతుంది కాబట్టి స్టార్టింగ్ end నుంచి that is S తో ఇండికేట్ చేసుకుంటాం, సో that is indicated as IS అంటామండి. Okay, and coming to the, so the current which will be total flowing to the resistance, throughout the resistance and inductance, so finally which is fed into the load. Sending end అయితే ఫైనల్కి వచ్చేదండి రిసీవింగ్ ఎండ్, ఎక్కడికి వచ్చేది ఏమందండి, దట్ ఈస్ లైక్ ఏ VR. Receiving end voltage means R means receiving end, V means voltage, that is given as VR. Receiving end voltage means this is given as VR. So finally receiving end చేరుతుంది. So this is the basic constructional representation for the short transmission line. According to the parameters existing, this is the representation for the short transmission lines. Okay, and in the short transmission line there are different types of benefits is there. Okay, there are different types of benefits is there. So the transmission losses also very low when compared to the both medium as well as long transmission lines. Okay, why? Because when the length of the line will be increasing, then the automatically losses also increasing. For example, if you want to go for the like a medium or long transmission line, either long transmission line, here the length is increasing when compared to the short transmission line, then only automatically losses also increasing. Why? Because here length is increasing. Okay, according to the property of law of resistance, R is equal to rho L by A. R is equal to rho L by A. Already you know that, I think. R is equal to rho L by A. So whenever length is increasing, automatically so resistance also increasing. So that's why, so length increasing and అర్థమైందమ్మా, సో ట్రాన్స్మిషన్ లైన్ లెంత్ అని ఇంక్రీజ్ అవుతుంది. సో ట్రాన్స్మిషన్ లైన్ లెంత్ ఇంక్రీజ్ అయితే ఆటోమేటిక్ మనకి లాసెస్ అనేవి ఇంక్రీజ్ అవుతాయి. సో దట్ ఈస్ లైక్ ఏ సమ్ హార్మోనిక్ లాసెస్. సో ఇన్ టర్మ్స్ ఆఫ్ that is like a, so harmonic losses as well as both coronal losses and skin effects, all those prosthetic effects, all those of different types of losses will be existing whenever the length is increasing of so transmission line. Here basically we have to generally consider as like AC transmission line. Here coming to the medium transmission line, okay, so basically the medium transmission line which is may contains between 90 to 120 km. Okay, between 90 km to 120, which is very important. Okay, which is very important. The medium transmission line which is may contains between 90 to 120 km, 90 to 120 km. So So this can be represented as like a median transmission lines. Whenever the distance may contains below 120, it means basically whenever the distance may contains below 120 km of the total entire transmission line, that can be we have to consider as a like a medium transmission line. That can be considered as a medium transmission line. Please remember that, very very important. Okay. And also coming to the medium transmission lines, in this also some line parameters will be existing. In this also some line parameters also existing. So that is basically both resistance as well as inductance as well as capacitance. Okay, both resistance as well as inductance as well as capacitance, all those will be existing in the medium transmission lines. All those will be existing in the medium transmission lines. Okay, in the short transmission lines only both resistance and inductance only. In case of medium transmission lines, both resistance as well as inductance as well as capacitance also, another parameter will be also existing in that medium transmission line also. Okay, which is very very important. Please remember that. So coming to the here, so basic representation here. So one is the resistance is there. So this is a simple basic diagram for all those transmission lines. One is the resistance is there. So resistance we have to draw. Inductance is there, and also another one is the capacitance also is there. Okay, so this capacitance which is basically which is connected to the end of the total entire line, end of the total end of the entire line, and also which is connected to the shunt, which is connected to the shunt or parallel to the entire transmission line. Okay, the capacitor which is connected to the according to the connection of shunt, according to the connection of shunt to the entire transmission line. So that can be we have to simply represent to the medium transmission line. That can be simply we have to represent that to the medium transmission line. Okay, so this is connected here, capacitance also. So which will be connected like a shunt to the entire transmission line, which is connected to the here. This is the capacitance. So simply we have to indicate as some Xc. Simply we have to indicate as some Xc. Why? Because the capacitance also may contain internally some reactance property. That's why we can indicate as some Xc. Or simply you can add some C. Okay, simple capacitance. Okay, and also so this is the basic representation for the medium transmission line. Okay, this is the basic representation for the medium transmission line. Okay, so and also here also load also we have to connecting. So that load also maybe so which is parallel to the capacitance, which is parallel to the capacitance, that is like this. So this is the load. Okay, so this is Xc, this is load. So this is the basic representation, construction representation for the medium transmission line, medium transmission line. Okay, so all those different same here also standing interval is Vs. So current flowing to the entire transmission line, that is given as Is, and also coming to the receiving end voltage, that is given as Vr. So this is the basic representation for the medium transmission line. Okay, and also one thing is there here, one thing is there very very important. According to the connection of capacitor, according to the connection of capacitor at the end of the total entire transmission line, at the end of the total entire transmission line, there are the transmission lines can be simply we have to identify or simply judged as a, in that one is the end condenser method, and condenser method, and second one is the okay, and second one is the normal T method, and second one is the normal T method, and third one is the normal phi method. Okay, and third one is the normal phi method. Okay, so according to the representation, or else also called as according to the construction of both line parameters, resistance and inductance and capacitance, the medium transmission lines can be designed as end condenser method, and as well as normal T method, as well as normal phi method. Okay, so these are the according to the construction of line parameters. Okay, so coming to the end condenser method. Okay, coming to the end condenser method here. So if you observe this diagram, you can clearly understood. Okay, so this is like a end condenser method. This is the first method. Okay, here condenser means that is like a capacitor. Here condenser means that is like a capacitor. Okay, so the capacitor which is connected to the entire end of the total line parameters here. So the capacitance which is connected shunt to the total line parameters means here end. So that means here itself which is connected to the entire end of the both transmission line, I mean line parameters. So that's why simple we can call it as end condenser method. This is called as coming to the representation of end condenser method. Okay, as well as, so coming to the normal T method, so T method means here basically, okay, so coming to the normal T method, here basically on resistance as well as inductance is there, okay, and also here the capacitance which is connected between resistance and inductance. Here the capacitance, according to the connection of capacitance, we have to indicate to the different types of all those things, okay. So coming to the normal T method here, so the capacitance which is connected between both resistance as well as inductance. Here also some sending end voltage is Vs, so current flowing to the entire line will be given as some Is, okay. Here also which is like a some load, okay, which is like a load. So this is the total representation as a normal T method, okay. So this is like a some resistance R and like a some XL, this is like a some C or some C by 2 or also called as some XC, whatever may be that we have to indicate as. So this is the representation of like a T type, like a normal T type, okay, normal T type, representation of medium transmission line, okay. And also coming to the, so current flowing to the entire, so capacitor is given as some IC here, okay, this is IS, and current flowing to, this is like a junction here acting like a junction. From this junction some current will be flowing, that is given as IC, so capacity in the current flowing is given as some I, that is given as some IC, okay. So this is the representation of normal T method, okay, in the medium transmission. And also coming for the normal phi method, here the capacitance which is connected both side, from sending end side as well as receiving end side, okay, also, and sending end also as well as receiving end also, the capacitance both side connected, then only we have to consider as a normal phi method, okay. So if you observe this diagram, okay, here also some small modification is there. So this diagram, so here also one capacitor is connected to the entire line, okay. Here also one capacitor which is connected to the entire line. So this is represented as a normal phi method, okay. So simply the phi can be represented like this, already know that the phi can be represented like this. So this is the representation according to like this also. So this is the normal phi method. And also here also some sending end voltage also given here, so that is given as some Vs. So current flowing to the entire line, that is given as Is. In this current flowing is IC to the capacitor, as well as, so in this also this is IC1, let us consider this is the IC1 for the first capacitor current flowing, and also this is the IC2, so this is the second capacitor will be flowing to the some current will be flowing, so that is given as some IC2, as well as here also some load is connected here. So here also some load is connected like this, so this is like this. This is the representation of normal phi method, okay. So ఇక్కడ కెపాసిటర్ ఏం చేసామంటే, సో సెండింగ్ సైడ్ ఆఫ్ కెపాసిటర్ కనెక్ట్ చేసాం, యాజ్ వెల్ యాజ్ రిసీవింగ్ హ్యాండ్ సైడ్ కూడా మనం ఒక కెపాసిటర్ అనేది మనం కనెక్ట్ చేసాం. సో దిస్ ఇస్ ద రిప్రజెంటేషన్ ఆఫ్ నార్మల్ phi method, okay. This is the representation of normal phi method. So all those representations will be coming to the medium transmission line, okay. And also coming for the long transmission line, okay. So first of all, if you want to go for the medium transmission line, in this also some losses is high when compared to the short transmission lines. Why? Because here the length of the conductor will be increasing, that's why the losses also increasing, means itself basically below 120 km, already know that, okay. So below 120 km the total entire line conductor, so that's why the line loss also some small varying when compared to the short transmission lines, okay. And as well also some voltage, so change in properties in the voltage regulation also, happened, okay. And also coming to the long transmission line, this is the last topic in our concept today. Coming to the long transmission line, okay. In this long transmission lines also, basically we can contain to the both resistance as well as inductance as well as capacitance, okay. All those three parameters will be consisting in that particular long transmission line also. In this also basically here the distance will be mostly here considerable, means here whenever the total entire length of the line, transmission line length which is may contains above 120 km, above 120 km. Okay, above 120 km. So then only simply we have to consider as a long transmission line. Okay, then only we can simply judge as a like a long transmission line, means which may contains basically above 120 km, above 120 km. So after that it may be contains like 220 km or 300 km, like 500 km or 800 km, whatever may be the different types. So the ranges simply we can judge as like a long transmission line above 120 km. Okay, and also coming to the long transmission lines, in this also mostly heavy loss is there, like corona, skin effect and proximity effect, all those iron losses and copper losses, all those things also losses will be very high when compared to the both short transmission lines as well as a medium transmission lines. Okay, both short as well as medium transmission lines, in this also losses is very high. Okay, and also so voltage regulation also happened in this also, voltage regulation also, so changing happened also here. So between sending end and receiving end, some voltage regulation changing will be there according to the losses will be existing in that particular transmission line. Okay, and also coming to the long transmission lines, basic in this also may contains both resistance as well as capacitance as well as inductance. Okay, so like this, resistance and their inductance as well as capacitance we have to represent it like this also for the long transmission lines. Okay, this is the load, this is the resistance, and this is the inductance, this is like a capacitance. So this is the sending and current, some IR, IS. So like this representation will be coming to the long transmission lines. Okay, here the distance of the line may contains above 110 km, above 120 km. Okay, so this is the today our class subscribers. Okay, if you have any doubt, please put on the comment box. I will give you reply, as well as I need your support always. I need your encouragement. Okay, and also so please daily visit our channel for more new interesting classes, which is the all classes which will be useful for the both technical peoples as well as non-technical peoples also, as well as some general peoples also. All kinds of different types of peoples will be useful for our classes, useful for our classes. Okay, please daily visit our channel. If you have any doubt, please put on the comment box, no problem, I will give you a reply. Okay, anytime. Okay, so thank you one and all, thank you very much. So I need always your support. Thank you one and all, thank you.